Hello guys, I'm back. Today I'll talk to you about what is the working process between the process simulation and the purchase of equipment. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to get hundreds of contents related to chemical process engineering and plant design. To have equipment installed in the field, the chemical process engineer must do much more than just the process simulation of a process. We need to develop documentation, we need to do feedbacks for the suppliers and do a lot of other activities. So to have a pump installed in the field, let's use as an example a pump that I need to install in the field. The first thing you must know what is the requirements in terms of products. In this way, what is the requirements for the battery limit downstream of your pump? You need to know the pressure, we need to know the flow, and of course that you need to know what is the fluid that is being pumped. So this is the starting point of a project. And based on that, you need to know what are the conditions of your feed stream to the pump. Temperature, pressure, composition of the fluid, and etc. So with those information, you are able to do the calculation of the pump head, the pump brake shaft power, and the NPSH available for your system. So these are the minimum information that you will deal as a chemical process engineer working with plant design in the point of view of process simulation or heating material balance. In this way, as we are talking only about one pump, we can use process simulation softwares, we can use spreadsheets, or we can use hand calculations to define the pump head and flow and inform the fluid characteristics for the supplier. But with this information, your job as a chemical process engineer is not ended, is not finished, because you need to develop a document where you have the minimal process conditions for the supplier be able to choose the correct equipment to be offered to your company, to your project manager, and etc. So depending on how big is the company where you are working to, you will develop a process data sheet for equipment, in this case pump, and the mechanical engineer, the equipment engineer will get those information and transfer that to a specification data sheet for pumps. Depending on the size of the company, you will not have an equipment engineer, you will not have a mechanical engineer. So you, as a chemical process engineer, will define the major conditions and develop the specification data sheet for the pump. And in the specification data sheet of the pump, there is much more than only the process conditions. We need to inform the electrical requirements, we need to inform the hazard area, if there is hazard area or not. We need to inform if the pump will be installed indoors or outdoors, because all of this information will change the specification or the requirements of the pump, and of course that will change the cost, the OPEX eventually, and also the schedule to be delivered to the plant. And that, in some cases, can be the crucial part or the crucial information to the decision of a supplier. So once this specification is finished, it's time to move this specification for the procurement, and most often the people or the team responsible to doing the interaction with suppliers is the procurement team. They will be responsible for doing the selection of at least 3 vendors. Depending on the compliance of your company, we need to have 3 vendors, because this way we can guarantee that the quotes and the process of purchase there is any kind of tricky or corruption. So this is as it happens. those suppliers will return with two kinds of documentation for the working process to the purchase of a pump or any other equipment. The first one is the technical part and also the commercial part. Sometimes these two parts are splitted and the commercial part is only available for the procurement team. It is usual when we have very amount of money. We are talking about $100,000 or $1 million of money to purchase an equipment or a system. So as a chemical process engineer, we will not have access to the commercial conditions of the purchase. And that do not matter for us. What matters for us is the technical part of the quotation, of the proposal. So you will receive some information from the suppliers, and when we are talking about pumps, most necessary documentation is the pump curve, because you will evaluate in the pump curve what is the efficiency of the pump, the NPSH required, and what is the range of flow and range of head of the pump. If the range offered by the vendor makes sense compared to the technical specification that you have done, you will say to procurement, or in fact you will fill a technical report telling that though that vendor was approved or that vendor was not approved because of that, or you will ask for clarifications in order that the vendor can update or review their quotation and fix what needed to be fixed. So currently I am dealing with a project and I am verifying some quotations from suppliers, and you must have very attention to the documents that suppliers send to you, because sometimes you will fill your process documentation or technical or specification data sheet with a unit of measurement of bar G, for instance, and the supplier will send you a data sheet with bar A. You will fill the technical specification with cubic meters per hour, and the vendor will send you a quotation with liters per second. And this kind of mismatching will take more hours to you evaluate if equipment is feasible or not for the process that you are dealing with. And do not be surprised if you verify that some information that was added to the technical specification is not complied by the vendors, because some way, for any reason, the vendor forgets to add something, or the person that developed the quotation, the technical part of the quotation, also can have mistakes. And for instance, currently I have done a technical specification for a compressor where I informed the barometric pressure, I informed the manometric pressure, and I informed the delta P for the compressor, what I want in the compressor. So if I have the barometric pressure and I have the manometric pressure, it's possible to do the calculation for the absolute pressure, that is manometric pressure plus barometric pressure. And as I informed the delta P, the differential pressure in the compressor, if I summing up the pressure drop, the differential pressure in the inlet suction, I have the discharge pressure. But what happens is that the barometric pressure is a function of the elevation from the sea level. As higher is my location, lower will be my barometric pressure. And by standard, most of the calculations performed in chemical process engineering and plant design is based on the sea level that has 1 atm as barometric pressure. So when a supplier sends to me a quotation, they, instead of considering the barometric pressure that was added to the technical specification, was very clear there, they assumed the barometric pressure as sea level. and because of that, the equipment are not able to fit to my process. So in this way, I need to give notes to the quotation, reply to them, and ask for doing the fixing and updates needed to the technical specification. I prefer to clarify all the questions with a meeting with the vendor. First, we do the technical specification, share with procurement, procurement shares with the vendor, vendor sends a proposal, I verify the proposal, I add the comments to the proposal, and in my point of view, I prefer to have a technical meeting with the vendor to clarify all the comments that I have in the proposal in order that we save time with too many reviews because someone didn't understand what was in the comments or what was shared. So in my point of view, this is a better way for working, for dealing with this working process of getting the equipment from the process simulation, the purchase of the equipment. So once the equipment is technically approved or not approved, if not approved, the vendors not approved will be removed from the bid, they ask for quotation, and those ones that has the technical specification approved will talk with the procurement, and there will be a commercial negotiation to verify which one of them will offer will give the better offer. Not always the lesser price wins. We need to consider also the schedule for delivery, the maintenance, the spare part components, if this equipment is local fabrication or if it is important. There are a lot of things to be considered when we are doing chemical process engineering plant design. So guys, with this, you have an overview of the work of a chemical process engineer dealing with process simulation to purchase of equipment, and this working process is very similar to many of the equipments that you'll find in plant design. This is it. If you want to know more about chemical process engineering plant design, take a look in the next video that will appear to you right now.